Hello and welcome to this Island at Millis Netacard series. My name is Silence Madondo and I'll be taking you through the first course of CCNA Introduction to Networks. And this is the first module, Networking Today. So if you have any questions, leave a comment and I'll make sure I'll respond as soon as I can. So the module objective is to explain the advances in modern technologies, and the table summarizes some of the topics that we'll be looking at. Network affecting our lives, where we look at the role being played by network in our lives. We will look at the different components that make up a network and how they are represented in a network topology. Then we will compare characteristics of different type of networks. I think most importantly the local area networks, LANs, and the wide area networks, WANs. From there we'll look at different internet connections and explain how LANs and WANs are interconnected to the internet. Then we'll describe the basic requirements of a reliable network. I think we'll look at the network infrastructure there and what makes up a reliable network infrastructure. From there we have network trends, where we'll look at different trends that we have that have definitely changed the way we interact today. Then we have network security, where we'll look at the different type of threats that we have and the solutions to those threats. Then we have the IT professional, where we look at opportunities, jobs in the networking field, and what exactly will you be doing after finishing this course. Get into how networks connect us. I think it's important to begin with defining what a network is. Basically being a system of interconnected devices connected with the goal of communicating and sharing of resources. So we have an interconnection of devices. This can be two devices, a million devices, and with these new emerging technologies, your IoT, your 5Gs, your cloud computing, this can be up to a billion devices interconnected. Now that's what a network is, and the role they play in our lives, I think, is undeniably huge at this point, because just recently turned into COVID-19, and I think networks were the forefront of almost everything that we did, from the way we communicate with the outside world, obviously, the way we communicate, our WhatsApps, our social medias, the way we do our business, online banking, the way we do our learning. We had e-learning. I think the education system, our education system, changed rapidly after COVID, and networks were at the forefront of that. So I think networks play a very huge role in our daily lives. With these networks and the technological advancements I just mentioned, IoT, 5G, cloud computing, what we now have are human networks. We now have global communities. We now have a world without boundaries. And what we mean, I can communicate with anyone in any part of the world from wherever I am. That's a global community. I can share files Nemonarum China and Rim Zimbabwe. That's a world without boundaries. So I think with that said, we thank God for networking. A network is made up of different elements. We have the host, which can be any device that is connected to the network. That can be your PC, your laptop, your switch, your router, your servers, anything connected to the network. And these hosts are uniquely identified by what we call an IP address. We'll later on look at IP addresses. For the roles they play, um, computers can be clients, computers can be servers. Clients being computers that request for information, and servers being computers that provides the information. A perfect example there, Google. If you Google anything, what basically that means is you are requesting for information from the Google server, and the Google server provides that information via a web page. You almost want anything that you Googled over the web page. So basically, that is what happens. For the server types, we have the table there. We have the email, the web, the file, and they respectively give access to emails, web pages, and files. Now, a device can also play both roles, being a client and being a server at the same time in the network. Now, in this situation, we now have what we call peer-to-peer networks. It comes with a number of advantages: very easy to set up, very less complex, and cheap. Why? Because with two PCs, you can start sharing information without need of other complexities, no switches, no routers, no configurations, nothing. However, with no centralized administration, you have issues with security and scalability. Also, with the band limitations, network congestion, inefficient protocols, that can lead to peer-to-peer networks being very slow. Other network elements, we have end devices, which can either be the source or the destination of a transmitted message. And as stated earlier, these are uniquely identified by an IP address. We also have intermediate network devices, which are the devices which interconnects the end devices. Examples here, we have switches, wireless access points, routers, firewalls. The function of the intermediate devices, they include regeneration and retransmission of data signals. They also maintain information about pathways that exist in the network, that is the routing information. They also notify other devices of errors and communication failures in their network. To demonstrate the roles the end devices and the intermediate devices plays in the network, we have an illustration here of two local area networks and an internetwork, which can be a campus network or the largest one, the internet. Now, the originator of the message, the end devices, if I send a message, if I send a packet, there goes the packet. What happens when it reaches the router? The router finds the best path to the other network or to the destination of the packet. And that is one of the roles that the intermediary devices play, maintaining information about what pathways exist in the network. So there goes the packet and it gets to the receiving end, which is the other end device. Now, to the last network component we are going to discuss, we have the network media, which is basically the vehicle which transports the message from the source to the destination. Illustrated there, we have the three different types of media: copper, which uses electrical pulses; fiber, light pulses; and we have wireless, which uses electromagnetic waves to transmit its messages. As for the criteria for choosing network media, we have four main criteria. One, the maximum distance the media can successfully carry the signal; the environment where the media is to be installed; the amount of data and speed; and the cost of the media. To put that into perspective, I think an example, we can have comparison here: copper and fiber. Distance. If you want to install a network in a very short distance, a local area network, copper can be a very good choice. But over longer distances, wide area network, you see that copper is massively affected near attenuation. Therefore, fiber is a much better choice. Environment-wise, wireless, for example, tikaona panama buildings akawanda, a lot of interference, mountains, and all that, wireless cannot be a very good choice. So you choose other media over wireless. Cost of media, over longer distances, fiber is very cheap. but over short distances it can be very expensive, which is as well vice versa for copper. Very cheap short distances, but very expensive longer distances. So choice of media is also affected by the cost. Then for the amount of data, you see that Ethernet cables for 100 megabytes per second, they are capable. But if we go beyond that, gigabytes, you need different types of media, maybe wireless or fiber optic. So from the network components, we go to the network representations, where we have diagrams with symbols being used to provide an easier way of understanding how devices are connected. So illustrated there, we have a couple of devices and intermediary, and different types of media being represented by symbols. Over the course of this course, I think you'll pass by some of those symbols, especially Potato Packet Tracer. You definitely have to become familiar with those symbols. Still on the network representations, we go to the topology diagrams, which are a visual representation of the arrangement and connections of devices within a network. Two different types there, the physical and the logical topologies, with the physical topology showing the devices themselves and the physical locations of those devices. I can see different rooms there, different racks and different shelves. Now on the other hand, the logical topology shows different ports and addressing schemes. I can see networking address there, and fast and giga ethernet ports. The two most common type of networks that we have the local area network and the wide area network, LAN and WAN respectively, which vary in terms of the size, that is the geographical size of the area covered by the networks, the number of users, and the type of services that are available, as well as the area of responsibility. So that it can as well be the different characteristics which can be used to define what a LAN and what a WAN is. From the diagram there, we can see three different local area networks and one wide area network, with as you can see, the one being the interconnection of different local area networks. Still discussing wide area networks, we have the largest wide area network being the internet, which is just a collection of interconnected local area networks and wide area networks which cover the whole world. Now, who owns that? It's definitely not an individual or a group. Uh, However, there are different organizations which help maintain the structure and the standardization of the internet protocols and processes. We have three of them there: IETF, ICANN, and the IAB. Other type of networks, we have the intranets and the extranets. With the internet being a private collection of LAN and WANs only accessible by the members of the organization. On the other hand, the extranet provides a secure, controlled access to users outside the organization. So I think the only difference there, one is within the organization, and the other can provide access to users outside the organization. Now that we've defined what the internet is, we now look at the internet access technologies, which are basically ways that we connect to the internet. So how do users and organizations connect to the internet? Listed there, we have different ways that we do that. The broadband cable, the DSL, the wireless ones. I think our Wi-Fi falls under that. We have the mobile services, which most of us use. Those are our Econets, Net1 lines. Then we have the business class interconnections, which include the business DSL, the leased lines, and the Metro Ethernet. So for home and small internet connections, we have cable, which offers high bandwidth internet offered by cable television. I'm not familiar with that one. We have DSL, which offers the same with the connection running over the telephone lines. So my telephone lines, I'm one my landlines, which still we have for some. That is where the connection, the internet connection is. We have cellular. I think everyone is familiar with that, which uses the internet connection over the phone network. Then satellite. I think Elon Musk ndiye kupisa nenyama satellite izvi. So we have satellite internet connection and dial-up telephone, which is an inexpensive low bandwidth option using a modem. For business internet connections, these ones require higher bandwidth because there's much information which is being transmitted compared to small offices. They also require dedicated connections and managed services. And some of the type of connections that are suitable for that, we have the dedicated leased lines, the Ethernet 1, which extends LAN access technology into the wide area networks. We also have DSL, which is business DSL, and satellite. Satellite mask as well applies to business internet connections. With converged networks, we now have a situation where a network is capable of delivering data, voice, and video at the same time with the same network infrastructure. So instead of having different infrastructure for different types of traffic, with converged networks, we have eliminated that problem. This also comes with a number of advantages, from cost saving, obviously, because takushandisa only one set of infrastructure. We also have enhanced QoS, enhanced the quality of service, and improved scalability and flexibility. So now that we have a network, you will need a reliable network. I think a reliable network is crucial for the way we communicate. Imagine you want to Google a page. You Google a page by internet, but page actually is continues saying reloading. We cannot access the page. What that means is you don't have a reliable network. You make a WhatsApp call or a video call, and the call will drag. You don't have enough bandwidth to make the video call. That is an unreliable network, and technically it means whoever is providing you a service, they don't have a reliable network architecture. And by network architecture, basically this is the sum of the hardware, your routers, the switches your service provider use, the topology, which type of topology they use also affects reliability. We have the protocols they use, the network management. That sums up what we call the network architecture. And there are four basic characteristics of that architecture which needs to be addressed to meet user expectations. So we have we have fault tolerance, scalability, quality of service, and security. Now for the first characteristic, we have fault tolerance. which is the ability of a network to continue functioning even in the event of failure. Now, how is that achieved? It's achieved through what we call redundancy. Now, redundancy, it can be in the form of backup devices or backup parts that are available to take over in case of failure. In the diagram there, we can see we have a backup link. We can see if a packet is sent through this switch to this router, and if this router fails, you see we have another link that goes to the internet, and you can access whatever you want to access. As well, we can have a backup router here. If we have a backup router, it means if one of the routers fail, then another router will be used. So basically that is what redundancy is, and it provides what we call fault tolerance in a network. Moving on, we have scalability, which is the ability of a network to expand without impacting the performance of services on existing users. So basically what scalability does, it ensures that the network continues to function properly as the size of the network grows. And how is that achieved? One way of achieving that is investing in network hardware that supports modular expansion. Now, if you have modular switches or modular routers, what that means, you can have modules that can be added to the switch, and they will provide additional ports or additional interfaces when needed. So when your network is growing, you just add a module which provides you with additional ports and interfaces. With quality of service, what we have are mechanisms that control traffic and ensure performance of critical applications in the network. So two types of QoS highlighted there. We have first in, first out, and priority queuing, with the focus of QoS being prioritizing time-sensitive traffic. So what we have with QoS, it ensures that critical applications, critical network services, for example, voice, video communication, they always receive priority over other types of traffic. Why? So that they are delivered without delay, and they are delivered without packet loss. From the diagram there, we can see we have two types of traffic there: web traffic and voice traffic. By no shikapa router, the router will prioritize the voice traffic over the web traffic. Why? Because if I make a call, packet loss, ipapo pakatika delay, communication wise, and chatons will do. But if I have a web page, even if pakata delay, the page will load and it lasts in the consequent information and under load I say. So basically that is what encompasses what we call quality of service. Lastly, we have network security, which refers to the protection of network infrastructure and information. So basically having two types of issues to be addressed: the network infrastructure security and the information security, with the first one being the physical security of the networking devices. My surveillance cameras, my access controls, my logs to prevent access to the networking devices. We also have protection from fire, protection from natural disasters that can damage your network equipment. With information security, this is basically the practice of protecting information from unauthorized access. Now, the overall goal of all this is to ensure what we call CIA, with confidentiality being preventing unauthorized access to information, and integrity ensuring that information is accurate, complete, and reliable, and availability ensuring that information is accessible when needed, and that systems and networks are operational and reliable. So in this digital world that we now live in, you see that technology is always advancing. As well, the roles of the networks have to adjust to keep up to the technological advancements. Now, in this topic, we discuss some of the recent trends that affect the organizations and consumers. So, we are going to discuss the bring your own device, BYOD, the online collaborations, video communications, and cloud computing. With BYOD, what you have is so I'm going to explain this using an example of a company. So a company that allows users to use their own personal devices instead of those that the company provides. So now what you now have is a situation where munhu anokwanisa kushandira from wherever they are, anokwanisa kushandira ari kumba, provided they have a phone, smartphone, they have a tablet, they have a laptop. And this comes with the benefits of increased flexibility and definitely cost saving for the company. So basically that summarizes what bring your own device means. So with online collaboration and video communication, they sort of go hand in hand, with the video being used for communication, collaboration, and entertainment. Collaboration is definitely a very high priority for businesses and in education. You see that in businesses, we will collaborate and we will work with each other over the network instead of physically meeting for us to be able to collaborate and work. In education, we have students collaborating and assisting each other in learning, developing team skills, and working together on a team project. An example of a collaboration tool that Cisco has, we have Cisco WebEx, which gives users a way of instantly connecting and interacting. So what WebEx does, it posts images, you can post images, post videos, you can post links, you can even send instant messages, which helps in collaboration. I think other examples of video communication tools, we also have Zoom, your Microsoft Teams there, Google Meet. I think those are the most familiar that we use. Cloud computing is definitely an interesting trend these days, and it refers to the delivery of on-demand computing services over the internet, and this includes server storage, databases, analytics, any other IT resources. So what happens is smaller companies that cannot afford to invest in infrastructure, data centers, or server and storage services, what they do, they will lease server and storage services instead of buying their own and maintaining their own physical data centers. With cloud computing, it allows us to store personal files, back up our data services, our data servers over the internet. We also have a number of applications now running on cloud, and it allows businesses to deliver to any device anywhere in the world. Now, what allows cloud computing to do whatever it does, we have what we call data centers, which are a facility. It can be just a building, a facility which stores and manages computer systems. So in this facility typically has your big switches, your routers, storage systems, the servers, and other security devices. For the cloud types, we have 4 types: the public clouds, which are available for the general public; the private clouds, only intended for specific organizations; we have the hybrid clouds, which are made up of 2 or more cloud types, with each part remaining a distinctive object, but both connected to the same architecture. We also have custom clouds, which are built to meet the needs of a specific industry, which can be private or public. Technology trends in homes. We now have smart home technology, which is a collection of devices and systems designed to interconnect and communicate with each other. So with that communication comes remote controlling and monitoring of the devices using a smartphone or a computer. Examples, we have lighting systems where you have a bunch of sensors in a room. They know kind of room missing a light. If it's dark in the room, light automatically switches on. If light is coming from outside Kwachena, Zwarabuda, the light automatically switches off. We have temperature control systems, sensors which control the temperature, security systems, entertainment systems, a lot going on in smart home technology. Now, it can also be used to automate routine tasks, monitor and manage energy usage. Smart home technology will become more as home networking and high-speed internet technology expands. It's already becoming more common. We now have introduction of IoT, 5G, cloud computing as well, meaning smart home technology is on the rise. Another trend that we have power line networking, which makes use of existing electrical wiring to connect devices. Very useful when wireless access points cannot reach all the devices in the home. Now, instead of having, for example, additional Ethernet cables being installed, additional access points being installed, we can use the existing electrical wiring in our homes to exchange information. What we need, it is made possible by sending data at certain frequencies. With wireless broadband, we have a type of high-speed internet service that is delivered through a wireless network. So what your internet service provider does, your wireless internet service provider, it connects you to a designated access point or hotspot. So you have an antenna installed outside the house, and it provides with connectivity for all the devices in the home. It basically uses the same technology that is used by the smartphone. We introduced network security as a characteristic of the underlying architecture of a reliable network, and we understand the importance of network security because a network can be breached, giving threat actors access to personal information. Therefore, securing a network is crucial. Now, it involves techniques that are used in order to secure data and to mitigate those threats. Definitely a top priority for network administrators. So in this topic, we are going to discuss some of the threats that we have, which can be internal or external. With external threats, we have viruses, worms, Trojan horses, which are malicious software that infects the computer or the networking device. They usually corrupt or delete files or even steal private information from the networking devices. We also have spyware and adware, which are types of software installed on a user's device and secretly collects information about the user. Zero-day attacks, these are attacks that occur on the first day of vulnerability. Threat actor attacks, where a malicious person attacks user devices or networking resources. We have denial of service DOS attacks, which slows or crashes applications and processes on a networking device. Ways that DOS can be carried out, we have traffic flooding as an example. We have resource exhaustion, another example. Then we also have data interception and theft, where this attack captures private information from an organization's network. Identity theft, where an attacker steals the login credentials of a user in order to access private data. For the internal threats, we have lost and stolen devices, that can give that can have unauthorized personnel having access to information. Then we can also have accidental misuse by employees. Now that we've introduced security threats, there needs to be a solution for that. And the security solutions are implemented in multiple layers using more than one solution. That is so that if one security component fails to identify and protect the network, another component may succeed. Now, examples of the security components we have for small office networks, we have antivirus and anti-spyware software that is installed on the end devices. We also have firewall filtering, which is used to block unauthorized access to the network. Now, for the larger networks, we have additional security requirements. Examples: dedicated firewall systems, access control lists, which filter traffic based on IP addresses and applications. We also have intrusion prevention systems, that is the IPS, which are security tools designed to detect and prevent unauthorized access in real time. Lastly, we have visual private networks, which provide secure access into an organization for remote workers. So with the new updated CCNA, we now have 3 courses and 1 exam, which covers the fundamental topics of all network technologies. Main focus being on IP foundation and security topics, wireless, virtualization, automation, and network programmability. Upon completion of this certification, it demonstrates that you have a knowledge of the foundational technologies, which are we have routing, switching, network protocols, network security, wireless networking, Ethernet, TCP/IP, and it ensures that you stay relevant with skills that are needed for the adoption of next generation technologies. We mentioned already cloud computing, IoT, 5G, edge computing, SDNs, etc. Now, as far as jobs go, CCNA validates the ability to install, configure, troubleshoot, and operate medium-sized networks. So if you want to be a network engineer, an administrator, a network technician, a consultant, CCNA is definitely the point to start. Now, kwekushandira mukunoshanda kupi? If there is a company and if there is a network, you definitely have a job there. So jobs may be found in a variety of industries, including technology, telecommunications, healthcare, finance, and government. So as far as I'm concerned, everywhere there is a job for you. All the best with your CCNA studies.